Explorer-1, NASA's farthest-traveled shuttle, proceeds with its exceptional venture through space, obediently sending significant information from the deepest areas of the universe. For almost 50 years, this uncommon space test has altered our comprehension of space. However, as of late, the rocket has been communicating terrifying information back to Earth, leaving the whole space industry in shock. Are these terrifying information the consequence of a specialized glitch or the exercises of extraterrestrials? Go along with us as we cover reality behind these stunning transmissions. Starting from the beginning of time, researchers have been enraptured by the secrets that lie past our divine boundaries. This interest prompted the notable send-off of the Explorer-1 and Explorer-2 rockets, among other momentous space missions. These notable missions, which have been discussed for a really long time, began with a send-off of Explorer-2 from the celebrated NASA Kennedy Space Center on August 21, 1977. 14 days after the fact, on September 5 of that very year, Explorer-1 went with the same pattern. These twin tests, gauging a significant 720 kilograms each, identical to that of a little vehicle, were pushed into space during an interesting arrangement of the external planets. All through their mind-blowing odyssey, these valiant adventurers explored assorted directions and speeds, prompting a critical second on December 15, 1977. Explorer-1 outperformed its indistinguishable twin, attributable to the varieties in their ways. From that point forward, Explorer-1 has turned into an important asset, furnishing us with a wealth of useful information and unwinding space-related secrets. Before we jump into the Explorer's unnerving new disclosure that stunned the whole space industry, how about we investigate the striking pictures caught by the space apparatus during its pivotal Jovian imaging mission in 1978. Explorer-1 was positioned around 265 million kilometers from Earth. From this vantage point, it communicated a stunning number of photos back to Earth. In January 1979, it set out on an unprecedented 100-hour try capturing a hypnotizing time-pass film displaying 10 turns of Jupiter. A cornucopia of 3,750 pictures permitted us to observe Jupiter's great dance in distinctive detail. In the ensuing months, Explorer-1 wandered through the Jovian moon framework where it made a surprising disclosure: the presence of a minute ring circling Jupiter. Moreover, 2 new moons, Theia and Medes, were drawn out into the open, further growing comprehension. We might interpret Jupiter's exciting domain to guarantee a protected entry and forestall a potential crash with Titan, one of Saturn's moons. Remedial moves were executed. Explorer-1 proceeded with its heavenly journey around Saturn, uncovering 4 extra moons: Memers, Enceladus, Tethys, Donon, and Rhea. With the fruition of the Saturn mission, researchers chose to close the Explorer planetary mission, impelling both Explorer-1 and Explorer-2 past the bounds of our nearby planet group, jumping through space at a shocking pace of 325 million m each year. In January 1990, another part started: the Explorer interstellar mission. It was during this stage that Explorer-1 delivered the absolute most notorious photos in history, deifying the Sun and most of the planets. One person who assumed a crucial part in broadening the missions past their introductory targets was the prominent cosmologist, K.L. Sagan. As an individual from the Explorer mission's imaging group, Sagan oddly supported catching one last arrangement of pictures, a goodbye gift to humankind. Again, despite everything, his unfaltering assurance proved to be fruitful. On February 14, 1990, Explorer-1, situated 6 billion kilometers from the Sun, left on a visual excursion. It is well known as the "to catch what nearby planet group" family photograph. These amazing pictures, adding up to 60 in number, added to the rocket's noteworthy assortment of 670 photos during its experience with Neptune. Explorer-2 accomplished an exceptional accomplishment. It recorded breeze speeds outperforming 1 mile per hour, making it the quickest wind of all time reported inside our planetary group. As the space apparatus wandered inside 2980 MES of Neptune's sky-blue methane-rich environment, it presented to us remarkable bits of knowledge into this far-off divine body. Remarkably, Neptune's largest moon, Triton, was divulged as one of the coldest regions inside our planetary group, with surface temperatures diving to a frigid short 391 F. Triton's peculiar elements, like its nitrogen gas regurgitating ice volcanoes that pushed frosty particles 5 miles into its dubious environment, further enamored our minds. These phenomenal disclosures extended our comprehension of the enormous variety and unpredictability of heavenly items living in the farthest reaches of our planetary group. Try not to go any place. The Explorer 1 spaceship has as of late made one of its most alarming revelations. Above all, how about we find out what it has accomplished in the most recent 45 years? What are the accomplishments of Explorer tests? The achievements of the Explorer twin tests have been absolutely unprecedented. More than 40 years prior, their initial perceptions of Jupiter and Saturn's moons left analysts in wonderment and broken past suspicions about these far-off universes. These moons, once remembered to be dormant and vigorously scarred like our own moon, ended up teeming with geographical action. Explorer 2, specifically, accomplished several amazing achievements during its journey. It impacted the world forever in 1986 by turning into the first rocket to fly by Uranus, and only 3 years after the fact, it achieved one more momentous accomplishment with a flyby of Neptune. Right up to the present day, it stays the sole space apparatus to have left on such a way. As the Explorer space apparatus proceeded with its excursion, NASA executed different measures to drag out its functional life expectancy. Over the beyond 3 years, unnecessary parts and warmers have been deactivated to monitor energy, ensuring that these courageous travelers can proceed with their mission well into the following 10 years. Their assessed mission end date is set for 2030. For the researchers and architects who have been associated with this unprecedented undertaking from the very beginning, the zenith of the Explorer missions is both a snapshot of pride and a hint of despairing. Their relentless devotion and resolute endeavors have far surpassed their underlying assumptions. The abundance of information returned by the explorers has given priceless experiences, filled various logical disclosures, and ignited the creative mind of incalculable analysts and space devotees. Explorer 1 and Explorer 2 were no ordinary rocket. They were carefully planned as steady stages with a turn rate more than 15 times more slow than the hour hand of a clock. This design decision limited visual obscuring as the shuttle caught pictures and information while leaping through the vastness of space. Even before their experiences with the external planets, their great imaging abilities started to astound researchers and the public alike. The rocket started sending pictures of Jupiter a while prior to arriving at the gas giant. These early pictures, displaying the whirling mists and famous extraordinary red spot, enchanted crowds at NASA's Jet Propulsion Laboratory. However, it was the disclosure of dynamic volcanoes on Jupiter's moon Io that truly took the spotlight. Io, marginally bigger than Earth's moon, ended up being the most volcanically dynamic body in our solar system. The space apparatus instruments identified curious signs from Io, which were affirmed by the clear pictures they caught. Transcending volcanic crest and a surface scarred by volcanic material discharges were revealed. Peel, one of Io's most conspicuous volcanoes, has emitted with a power multiple times more prominent than Mount Everest's level, covering an area almost the size of France. While the rocket's cameras were at last shut down to moderate power and memory before their excursion into interstellar space, it is actually important that the photographs they caught didn't incorporate Mercury and Mars for different reasons. Notwithstanding the Explorer 1 and Explorer 2 interstellar tests, NASA has additionally worked other outstanding shuttles like Trailblazer 10, Trailblazer 11, and New Skylines. Explorer 1 passed by Trailblazer 10 on February 17, 1998, denoting the occasion at the point when Trailblazer 10 turned into the most far-off shuttle. Explorer 1 proceeded with its single journey for an additional 14 years before at last entering the interstellar climate on August 25, 2012. In spite of the fact that there could have been no other space tests in sight to find, NASA didn't openly report this striking accomplishment until 2013. What are the methodologies utilized that guaranteed the outcome of the Explorer missions? In the amazing Explorer missions, one method stood out as genuinely brilliant: gravity help moves. These moves played a vital role in driving Explorer 1 and Explorer 2 on their venturesome mission to explore the outer ranges of our planetary group. To come to these far-off objections and assemble important information, the space apparatus required something other than their own impetus frameworks. They required a boost, and gravity helps provided just that. Imagine the two valiant rockets, Explorer 1 and Explorer 2, set out on their stupendous tour of the nearby planet group. As opposed to depending exclusively on their motors, they participated in a divine hit the dance floor with some of our solar system's heavyweight planets. This complicated movement permitted them to use the gigantic gravitational force of these monsters to slingshot themselves on their way. Thusly, they monitored valuable fuel and acquired the speed expected to visit different objections. Let's dive into the nuts and bolts of gravity assist, otherwise called a gravitational slingshot. The idea behind this move is to move some of a planet's force to the shuttle as it passes by. Picture Explorer 1 moving toward Jupiter, a huge gas giant with a gravitational draw to match. With careful accuracy, Explorer 1 swung by Jupiter at the perfect point in speed. Jupiter's gravity pulled at the rocket, speeding it up to a higher speed and giving it a vast help. Performing a gravity assist move requires phenomenal accuracy. If done incorrectly, it could result in a shocking deviation from its planned course. The degree of precision required is astounding. However, the brilliant personalities behind these missions executed these gravity assists numerous times, propelling the Explorer space apparatus on a stunning excursion through the nearby planet group. Explorer 2, for example, used gravity assist from Jupiter and Saturn to reach Uranus and Neptune. These divine assists were of significant significance in making the fantastic visit conceivable. The Explorer missions owe much of their prosperity to these gravity assists. Explorer 1 proceeded to reach into heavenly space, with Explorer 2 rapidly taking action accordingly, all because of the accuracy of these moves. The idea behind gravity assist is simple, yet the execution is unbelievably perplexing. Explorer 2000T required a degree of accuracy where missing any of these slingshots might have resulted in a failed mission. However, the devoted people behind these missions were still up in the air and constant in their quest for information. While gravity assists played a critical part in exploring the universe, another critical part ensured the outcome of the journey of missions. The Deep Space Network, DSN, considered the interstellar phone line. It kept us associated with our brave explorer tests as they wandered into the incredible obscure. The DSN, albeit less flashy than a space apparatus, is similarly fundamental. The Profound Space Organization is an organization of enormous radio antennas, decisively situated around the world, including locations in California, Spain, and Australia. These titanic dishes, ranging from 26 to an incredible 70 meters in width, act as grandiose bull horns, working with communication with rockets going past our planet. Now, let's investigate the role of the DSN in the Explorer missions. The Explorer tests, outfitted with cameras, sensors, and instruments, served as our eyes and ears in the immensity of space. To make sense of the information they sent and to give them new instructions, a robust communication system was essential. That's where the DSN came into play. Imagine this scenario. Explorer 1, on its way to the outer reaches of the nearby planet group, transmits a message back to Earth. It's a weak signal traveling at the speed of light. As it crosses the cosmic expanse, the signal weakens. However, the huge radio antennas of the DSN are able to catch that whisper. They lock onto Explorer's weak signal, amplifying it and converting it into information that researchers can analyze. But the DSN doesn't just receive signals. It also sends commands. The Explorer missions are dynamic endeavors, requiring scientists and specialists to change plans, redirect the space apparatus, or tweak instruments. These commands are sent via the DSN, which transmits them into space to reach Explorer. Generally, it works with a two-way conversation among Earth and the farthest human-made objects in the universe. One striking part of the DSN is its steady activity. It operates enthusiastically, 24/7, listening for those distant signals. It's like an unblinking eye on the universe, ensuring that we stay connected with our shuttle even when they are billions of miles away. The Explorer missions stand as a demonstration of the power of cooperation and innovation. While the rockets left on their amazing ventures, the DSN ensured they were never truly alone. It overcame any issues between our planet and the unknown, enabling us to explore the outer planets and venture into interstellar space. Did Explorer 1 experience a glitch, or were aliens involved? Throughout its remarkable 45-year journey in space, the Explorer 1 space apparatus has remained healthy, steadily completing its mission. However, recently, specialists have noticed some peculiarities in its execution that have ignited interest and curiosity. Explorer 1 is currently communicating unconventional signals back to Earth, making it questionable about its exact location coordinates. What makes this discovery even more bewildering is that the initial data received from Explorer 1 was expected to be more lucid and understandable, leaving NASA researchers bewildered. Upon examination, researchers found that the offender behind the mutilated data was the Attitude Determination and Control System, ADCS. This embedded hardware is responsible for measuring, reporting, and changing the space apparatus position in space. It has an antenna guided towards Earth, enabling it to send data back home. It was revealed that the ADCS had unexpectedly switched to sending its telemetry data through a defective embedded PC that had been latent for quite a long time. NASA specialists were able to correct this by instructing the ADCS to resume sending data through the right PC. Consequently, uncorrupted data from Explorer 1 is again reaching NASA. However, the unanswered question is why the ADCS changed to the malfunctioning PC in the first place. While NASA researchers have put forward a theory that a broken command from another embedded PC might have triggered this surprising behavior, they still haven't pinpointed the specific reason. To make quick work of this mystery, Susan Dodd, the project manager for the interstellar mission, stated that they plan to conduct a thorough memory readout of the ADCS and fully analyze its activities. This in-depth examination aims to analyze the issue that led to the telemetry issue. It is significant that despite the irregular data transmission, the actual ADCS seems to be working properly, and none of the spacecraft's fault protection systems have been triggered. Consequently, Explorer 1 has not been forced into safe mode, and its signal remains of strength for parts possible. A factor contributing to this oddity is the harsh environment of space. Vast radiation and extreme temperature fluctuations can present challenges to the operation of a space apparatus like Explorer 1. Cosmic radiation consists of high-energy particles originating from distant stars and celestial bodies. These particles can enter space apparatus structures, causing electrical disturbances, data signal distortions, memory faults, and data corruption. Furthermore, temperatures in the outer reaches of space can drop to frigid degrees. Explorer 1 is also exposed to micrometeoroids, dust particles, and debris from space rocks and comets, which can significantly affect its operation. The rocket's plasma wave instruments have consistently detected dust impacts as they ventured into interstellar space. When a dust particle collides with the spacecraft, it is quickly disintegrated and ionized, creating